Okay, Newton's laws of motion. Before we get to Newton's laws of motion, we need to talk about what a force is. And we'll just describe it as a push or a pull. So if you can imagine something as being a push or a pull, then that's what we call a force. That's what we mean by forces. We need to define this term net force. So think about that word net, what that means. Students today told me it's like an overall force, kind of works. They told me, well, you know what? I can't really remember what else they told me, but um, it also kind of means like total force. Um, and really it means the sum of all forces, which we will write as sigma F. Sigma just means the sum, and F means the forces. The sum of all forces acting on an object. And let's just get an example here of the sum of all forces. So if I have a block and I push on it with a force of 10 newtons, just a unit, it's like an amount, and somebody else pushes on it with a force of 3 newtons, what is the overall force pushed on the box? It's kind of like the box is pushed with a force of 13 newtons on it, something like this. We wouldn't really draw it this way, but I'm just illustrating. The total sum of the forces is 13 newtons to the right, and forces are vectors, so we have to include the direction. Okay. What about another small example here? What if I have a box and somebody is pushing on it this way with 8 newtons of force, and someone pushes over here with 3 newtons of force? What is the overall sum total of the forces on the box? It is not 11 because we had to take direction into account. 8 newtons is pushing this way, 3 is pushing that way. We sort of subtract them, and the bigger one kind of wins there. So the net force on this would be, about 5 newtons, or 5 newtons, to the right. Okay, we should just subtract them. So that's what sum of all forces means, in kind of in a limited context there. Cool. So let's talk about Newton's laws. Newton stated an object at rest with no net force acting on it. So again, just imagine a block and there's no net force. That could be like 10 and 10 pushing against each other. Or it could just be a block with literally no forces on it. So just no net forces, like the sum total here is 0, and the sum total here is 0. It says if an object is at rest with no net force acting on it should be a word here, it will remain at rest. Oh, I'm sorry. Sorry, I'm making these videos at the end of the day. I'm very tired. It's fine the way it is there. Okay. Well, that's very amazing. You see a cup on the table, just a mug sitting there. There are no net forces on it, and so it just remains at rest. Okay, very profound. Let's move on to the second part of Newton's first law of motion. An object in motion, again with no net force acting on it, will remain at motion at constant speed in a straight line. This kind of goes against our intuition. If you have like a soccer ball and you kick it up, and it kind of does something like this, and eventually comes over here and comes to a stop. That's normally what we see things in the real world do. If you're driving your car, okay, just real quick car here, and you take your foot off the gas, you will essentially coast and come to a stop. So, your car would be, uh, whoops, it gave me the whole thing. Your car would be over here with 0 speed. Here, let's show it this way. Driving here with a velocity, let's say it's 10 meters per second, and then over here it's at rest when you let your foot off the gas. So most objects in life we notice eventually come to a rest, come to a stop. That's typically what we notice. What Newton is saying here that if you have a object with no net forces, but it's already in motion, it wants to continue at constant speed in a straight line. So contradicts our experience, but we do believe this to be true. And of course, constant speed in a straight line, that is a constant velocity. Cool. Newton's second law, net force acting on an object will accelerate, will cause an acceleration. Oops, accelerate the object. That means the object's speed and or direction will change. And so Newton's second law is really about this equation here. The sum, we know this now as the sum of all forces on an object equals mass of the object times the acceleration of the object. Newton's first law was talking about when no net forces are acting on an object, so something like these pictures I showed up here. What Newton's second law is talking about, what if there are net forces? And I'll just show a simple one. What if I push on this with 10 newtons of force, and this block has a mass m? Then Newton is saying, well, depending on what that mass is, will cause it to, well, it will cause it to accelerate, and depending on what that mass is, will determine the value of the acceleration there. Um, so let's define this. This is the sum of all forces. Which is in units of newtons. M is the mass of the object. Which is in kilograms. It's our standard unit. And A is the acceleration of the object, which is in meters per second squared. Cool. We'll spend a whole many days working with Newton's second law, uh, more so than the other laws. So we'll get plenty of practice with that one. And finally, Newton's third law. Um, these other two laws really have to do with one object. This one has to do with one object, mostly. And then Newton's third law has to do with two objects. When one object exerts a force on a second object, the second object simultaneously, that means at the same time, exerts a force equal in magnitude, so equal in amount, but opposite in direction on the first object. So this is a skateboard, and trying this person's arms really far out. Um, let's say you have two people that are on skateboards. There we go. This is person one, this is person two. When person one is pushing on the second one simultaneously pushes back on the first one with the same amount of force, but they are pushing in the opposite direction. So person one pushes person two this way, person two pushes person one that way. And of course, these two people will separate. So, so after they get pushed, this person will go this way, and that person will go the other way. I can't move them both, but anyway, there it is. Cool. That is Newton's laws of motion.